Okay, we'll start out with a overview of what we're going to cover in the next 3 days. It's a lot of material, and so we appreciate you listening for that long a period of time. So we want to create a positive environment here so that you can ask any questions you want. And even the simplest questions quite often are the most important questions to ask. These architectures are new. How to utilize them is really critical. Many people talk about we are hitting the power wall, or how small we can make the circuits on the chip. But the real wall we're hitting today is the human talent wall. It's how many people know how to get the most out of these architectures. So that's our mission here, is to give you information so you can get the most out of the computing systems. So I'm going to first, we do hands-on exercises. So we do about 30 minutes of presentations and then 10-15 minutes for exercises. That's not enough time to do all the exercises, but it's enough to get started. And you can't listen straight for 8 hours, so we try to break it up. The fingers learn more than the eyes and the ears do, so it really helps to do some of the exercises. So on the system that you have available is called the AMD Accelerator Cloud. And this system is set up with the AMD software stack, much like the system here at Tsukuba will be set up. And if you have any questions, you can contact either myself or Giacomo Capodaglio. He is actually going to help from Austin, Texas during this during these training sessions. He wishes he could be here, but he had a personal conflict, so he is going to stay up late and give some presentations. He can set you up with a key if you want to send him your information. He can do that fairly quickly. So I encourage you to do that. If you want to get an account, we can get you one by at least noon or by tomorrow. So we prefer to use public SSH public keys because they're more secure. We'll create those accounts, and those accounts will be kept on the system for several weeks. So if you want to do, I'm going to assign a lot of homework, sorry, but there's a lot of homework involved, and but you can do it on your own time and pick what parts you want to do, what's most relevant to you, what's most important to you. So logging into the AAC cloud is SSH with your username that you've requested, and then aac6.amd.com. We typically have about 10% of the keys we have to work to get to troubleshoot issues, but your keys were phenomenal, so I think we should have much less trouble with getting you onto the system. You can add to your .ssh config file this information here if you want to simplify your login. It's not required, but if you put that on your login, then all you need is SSH AAC or AAC6 if you use the number after the name. So with this, you can then log in with just SSH AAC. If you get prompted for a password, do Control-C and exit so we don't get you on the blacklist. Because we have a firewall set up and it will If you fail the login 3 times, it will put you on a blacklist. You can copy files in and out. This is a public system, so you are free to put on the system whatever you want if it's open and not sensitive code. So you can try the system out with your example code if you would like. So we set up this cloud system like it's what we call a model installation. We experiment with it, and this is a sample for how we suggest you set up your local system. And this is crowdsourced, so we get comments from people when we do the training, or they even submit a pull request to the repository, and we include them. This is using Lua modules, so you'll see these modules show up as you log in. We just recently put on ROCm 7.0.1, but right now that's the ROCm 6.4.1 is the one we have been using most heavily. Once you select that, you will see all the modules, all the software that is built with that ROCm version. So when you select that with a module load, you will start to see other modules with all the software that is for that ROCm version. You should have copies of all these slides available to you. I don't know if somebody can give us directions where, but they should all be available to you. And one of the reasons we make them available is there's a lot of little details you may need to go back and look at. This is all public information. You are free to share any of this information any way you want to, as long as you don't do a comparison to NVIDIA and start saying one is better than the other. That gets us into trouble. We actually, I have a lot of friends working at NVIDIA. We try to keep friendly relations with them. They're a great company as well. So here's all the software that we have built on top of the ROCm software. And for HPC applications, there are often a lot of software you need before you can start. We have the next generation Fortran compiler on the system. And with the ROCm 7.0 release, it is built within the ROCm software stack. But until ROCm 7.0, it was a separate module. And that's what we call these AFARs. So these are future releases. And so we are getting a release from the Fortran compiler team every month with the latest improvements they have made to it. They have made tremendous improvement in the Fortran compiler in the last year. And it's one of the best Fortran compilers for offloading, OpenMP offloading that is out there today. And they are actively working on it. So we're actually asking for bug reports on it, and they are fixing bug reports that actual codes are running into as quickly as they can. Okay, so if you email either Giacomo or myself, we will send that to the compiler team and add it to their list to work on. We have been using this compiler in hackathons over the last year, and the feedback has been tremendous. they are finding it very, very useful right now. There's still some bugs in the compiler, and we are actively trying to get those fixed. The Fortran compiler previous to this was from PGI back in 2018 and hadn't been improved. And we call that Flame Classic. So it hadn't been improved since 2018. So this is a huge advance for Fortran codes to have this compiler available. So for module commands, I'm not going to cover everything associated with modules, but some commands that are fairly common: module avail to see the modules, module load, module unload. So we do set the compiler flags in those modules so that a standard makefile will work. We also set these OMPI variables so that will change the wrappers in OpenMPI to build with this compiler once you load that module. You have 10 nodes on the system that you can use. The first line here are Peri-Peak air-cooled. These are pre-production nodes. So they were not being used, so we were able to grab them for these training workshops. And each of those has 4 MI300A chips on it, 4 sockets. We also have this SH5 node, which only has 1 MI300A on it. So you have 25 total GPUs to use. That should be enough, but you may occasionally find that you have to wait to use a GPU. We do ask that you be considerate and free up a GPU when you're done using. We had a workshop last week. We had 120 people on it, and there were only a few times that we had to wait. So these GPUs are extraordinarily powerful. It's really, really amazing how much computation you can do with them. And so sharing them is actually quite effective if you want to share those across people. And there's different ways of doing that if you want to ask about that during one of the breaks. So here's a picture of those nodes. We have 5 of these Peri-Peak Air. We have 5 of these SH5 nodes. And these are all pre-production parts. But they work fine. The only thing is that they didn't have the production cooling system on them. And so they may overheat. And we have one of them down in the workshop last week. So I count that as a success. We're using them. So I think it's the first node, SH5 node, overheated, and they're going to reset it in the next couple of weeks. We will be moving the system at the end of the year and from Dallas to Austin. And so starting sometime in November, the system will be down. We use Slurm with salloc, srun, and sbatch to get to the GPUs. And you reserve each GPU you want to use. So sinfo will show you the queues that are available. SQ will show you the jobs you have running, and you can cancel a job with scancel. So here's a few examples of commands you might use to get onto the system with a GPU. The front end is a fairly lightweight system, so we ask that you do your work on the back end. You can create a batch file and submit your jobs that way. And here's a sample of the commands that you would put at the top of your batch file for Slurm. And then we've installed a lot of additional software. If there's any software we're missing that you would like on the system, we can easily install it on the system. Okay. So that's sort of the introduction. Any quick questions before I go into the first presentation? I haven't broken anything yet, so no questions. Okay, let's go into the first.